Across the world, few industries shape modern life as profoundly as the trillion-dollar oil refinery sector. Every drop of gasoline, jet fuel, diesel, and plastic begins here, inside a machine the size of an entire city. This is a world of towering flare stacks, rivers of superheated hydrocarbons, and furnaces burning hotter than volcanic lava. It is a world that never sleeps, because shutting down costs millions of dollars an hour. Today we're stepping deep inside one of the most advanced oil refineries ever built, to see how raw crude, thick, dirty, and unusable, is transformed into the fuels that power civilization. And near the end, you'll witness the most dangerous moment in the entire refinery. A moment only senior engineers are trained to handle. Crude oil begins its journey millions of years ago, as ancient marine organisms settle on the sea floor. Over time, heat and pressure compress this organic matter into hydrocarbons, the foundation of crude oil. Today, supertankers carrying up to 2 million barrels approach massive ports around the world. Pipelines draw the crude into storage farms, where giant tanks, each the size of an arena, hold the raw material of the refinery. But crude oil is far from ready to use. It contains water, salt, sand, metals, sulfur, and dozens of contaminants. Before refinement can begin, the crude must be tested and classified: light or heavy, sweet or sour, clean or contaminated. Its API gravity, sulfur levels, and viscosity determine everything that happens next. The first step of refining is desalting, removing salt and water that could corrode equipment worth billions of dollars. Inside the desalter, water is mixed with crude and shocked with a powerful electrostatic field. Droplets merge and sink, carrying salt and sediment to the bottom. The crude floats to the top, cleaner and safer to process. Next, the crude is heated as it flows through heat exchangers and finally into a massive furnace. Temperatures climb to nearly 350 degrees Celsius, hot enough to vaporize the lighter hydrocarbons. This is the crude's final preparation before it enters the beating heart of the refinery. The atmospheric distillation tower is one of the most iconic structures in any refinery, often towering over 30 stories high. Inside this enormous column, heated crude enters and begins to separate, not by magic, but by physics. Each hydrocarbon has its own boiling point. As vapor rises through the tower, trays and chambers capture different fractions. LPG near the top, naphtha, kerosene, diesel, atmosphere gas oil, and the heavy residue that falls to the bottom. This single tower separates the crude into 8 to 12 major components. But the heaviest ones, too thick to vaporize, must be handled another way.
If we adjust the reflux ratio here, we can significantly improve the yield.
The data resulting in substantial energy savings.
A sample of the refined kerosene is taken, a clear indicator of successful distillation.
The heaviest part.
This residue, still very impure and difficult to process, represents the central challenge scientists face in extracting the target compound.
Some hydrocarbons are so heavy that heating them further would crack or destroy them. To protect their molecular structure, refineries use the vacuum distillation unit. By lowering the pressure, the boiling points of heavy oils drop dramatically. Now, at temperatures safe for the molecules, the heavy fractions separate cleanly. The vacuum tower produces vacuum gas oil, vital for cracking, and vacuum residue used for asphalt or further processing. This step unlocks value trapped in the deepest, heaviest part of the crude.
Pressure holding steady at 35. Maintain current levels on pump 2.
Okay, reading is stable here. Pressure gauge 4B is within nominal parameters. Moving up to the catwalk now.
Crude oil naturally contains far more heavy hydrocarbons than we need, but the world demands lighter products, gasoline, diesel, jet fuel, so refineries turn big molecules into smaller ones through cracking. Often called the Beast, the FCC unit is the largest and most powerful system on site. Here, vacuum gas oil enters a reactor at over 520 degrees Celsius. A cyclone of powdered catalyst tears long hydrocarbon chains apart. In seconds, they become gasoline, LPG, and valuable petrochemical feedstock. Meanwhile, spent catalyst is regenerated in a separate chamber, reaching temperatures of 760 degrees Celsius. In another unit, hydrogen is added under extreme pressure, up to 200 bar. This produces cleaner fuels like jet fuel and ultra-low sulfur diesel. This is where the refinery truly earns its value, turning the least desirable parts of crude into the world's most in-demand products.
The hydrocracking unit utilizes high-pressure and specialized catalysts to convert heavy feedstocks into higher-value products like diesel and jet fuel.
The hydrocracking process yields this: a stream of exceptionally clear, high-quality jet fuel, pristine and ready for use.
Emerging from the hydrocracker, this premium diesel is visually distinct, representing the highest quality fuel on the market.
Look at the fluctuation on the kinetics chart. The molecular structure is adapting.
I see it. Rerunning the simulation now to confirm the stability.
We need to optimize the heat exchangers here to improve the yield, but that impacts the pressure stability downstream.
The simulations show a 5% increase in the
After cracking, the fuel is still not clean enough. Sulfur, nitrogen, and metals must be removed. Hydrotreaters use hydrogen and high temperatures to strip away contaminants. What emerges is fuel that is cleaner, more stable, and safe for modern engines. Next, low-octane naphtha is transformed in reformer units packed with platinum-based catalysts. The molecules rearrange into aromatics and isomers, boosting octane and improving performance. This stage also generates hydrogen, which is fed back into the refinery to support hydrotreating and hydrocracking. Everything is connected. Every reaction supports another.
Platinum-based catalysts are essential for countless industrial processes, playing a critical role in modern technology.
Here in the Quality Control Lab, our GC machines analyze samples with unparalleled precision, guaranteeing safety and efficacy.
Gasoline is not a single product. It is a blend, often dozens of streams mixed together to meet precise specifications. Computer-controlled systems combine reformant, FCC gasoline, alkylate, isomerate, and additive. Inline sensors constantly measure octane rating, vapor pressure, sulfur content, stability, emissions performance. Only when all targets are met does the product earn the name gasoline.
These massive blending tanks are crucial for ensuring the homogeneity of the final fuel mixture before distribution.
The RV test measures the volatility of gasoline and is crucial for emissions control.
The final products flow into massive storage tanks.
Crucial
Some more than 100 meters across.
Of the sample.
Floating roofs prevent vapor loss and reduce emissions.
Provide continuous,
From here, the fuels travel by pipeline,
ensuring
rail,
the safety
tanker
and
trucks,
efficiency
or
of the
ships
fuel
to reach
pipeline
consumers
network.
around the world.
All
Every
parameters
gallon
are
is
within
tracked.
the green.
Every
We are
shipment
fully
documented.
compliant.
Because the global economy runs on precision and trust.
Excellent work, team.
The result of a complex multi-stage refining process. A perfectly clear and finished gasoline sample.
Here we see the innovative design of the roof seal and the critical safety mechanisms protecting the stored product.
That is the full journey of crude oil, from ancient seawater organisms to the fuels that move our modern world.
Control, confirm
Inside the
pipeline
trillion-dollar
pressure
refinery industry,
And
chemistry,
dispatch,
engineering,
reroute the
and human
outbound
innovation
shipment to
work
dock 2
together at a scale few
0400.
can imagine. This is the engine of civilization.
From our refineries to
Hidden
your
behind steel
destination,
walls, burning
we are
24
fueling
hours a day,
progress
powering
every
everything
day.
from cars to aircraft to the global economy itself. This is inside manufacturing, and this is the heart of the oil refinery.